1.3, 2, 3, 4, 5, 6 amp hours, but only 2 physical sizes? What kind of witchcraft is this? And when batteries fail, can it be fixed? Let's give it a shot. Firstly, this is not a how-to video. Battery fires is a real thing that should be taken seriously. Don't leave your batteries charging unsupervised, and if a battery gets damaged, please dispose of it. Just don't do anything you're not comfortable with. Don't burn your shop down. I'm going to start with a crash course in battery theory, so if you just want to see me try to fix a battery, jump to this point in the video. Okay, now that the slackers are all gone, let's start with the basics. To be perfectly honest, I don't know that much about the inner workings of battery cells. But you have a master's in electrical engineering. Yes, I do, but here's the thing. Batteries is mostly chemical, not electrical. That's why you get those spectacular fires when something goes wrong. So we're not going to talk about where exactly the energy is stored. What we're going to focus on is how batteries is used and why tool batteries have their sizes they have. Most everything that can nowadays, like tool batteries, electric scooters and bikes, uses one or more of these things, the 18650. You can see it as the beefier, more comforted cousin of the standard AA. It carries 3.6 volts nominally with a current capacity of about 1.5 to 3 amp hours. The amount of charge it can hold depends on how it's made. I think both the raw materials, the methods and the accuracy plays part. But now we're getting dangerously close to chemistry, so let's take a step back and just accept that the current capacity changes between them, but the voltage stays the same. I usually think of the voltage as how hard the tool can work, and the amp hours is for long it can keep working. I mean, this drill always takes 18 volts, but depending on how hard you're drilling, it will take different amounts of amperage. Okay, strictly speaking, that isn't true when you look at the fine print. The voltage differs depending on how much amperage can be provided. It goes from like 4 volts when the battery is fully charged down to just over 3 volts when it's almost depleted. And that's perfectly normal. I mean, it's the same thing that with your outlets at home. I'm willing to bet that none of you have exactly 230 or 110 voltage in your outlets at home. And that's perfectly fine. A voltage difference of plus minus 10% is perfectly acceptable at the appliance. The total power is the voltage multiplied by the current, and when you have more than one battery cell, there are different ways that you can connect them depending on what you need. These two have a capacity of just over 2.7 amp hours, and if we connect them in series, that's positive to negative, we add the voltage together, that's 3.6 plus 3.6 equals 7.2 volts, a number everyone who has played with RC cars recognizes. And this battery pack has a capacity of 2.7 amp hours. If the batteries have different capacity, say that one only had 1.7 amp hours, then when that one runs out, the pack would stop working and the last amp hour of the better one would go unused. If instead we connected them in parallel, that's positive to positive and negative to negative, we add the current, but the voltage stays the same. So this battery pack delivers 3.6 volts with a capacity of 2.7 plus 2.7, that's 5.4 amp hours. Here the batteries try to balance themselves, so if one of them has a bigger capacity than the other, it will attempt to move charge from itself to the weaker one. In other words, charging it. So no matter if you're connecting batteries in series or parallel, you should always try to match them as best as you can. That's why you're told not to mix old and new batteries. But enough theory, let's open up a battery and see what it looks like. So let's have a peek inside. I hope it's not a surprise to anyone that inside here we find 5 of these batteries, connected in series, adding up to 3.6, 7.2, 10.8, 14.4 and 18 volts. 10.8 being the size of the small Makita line, so those have just 3 batteries. 40.4 was the old big line, so those had 4 batteries. Now we have 5. Let's open up a big one to see the difference. And surprise, surprise, here we find 10 batteries. 5 in series and both of them connected in parallel, giving a total of 18 volts and twice the capacity. So for the smaller ones, each cell have the same capacity as it says on the battery, but for the bigger one, each cell has half the capacity of what's written on the side. So this means that you can add up batteries with less capacity to get out more of them, and batteries with less capacity of course is cheaper than ones with more. This brings me to a pet peeve of mine, the 3 amp hour battery, because this feels kind of like a scam. Here they can unload all the crappy cells and still expect you to pay full price, because this is the big casing. It weighs as much as the 4, 5 or 6 amp hour ones, but you just get part of the power. So if you have a drill or something that doesn't require that much power, I suggest going for a 2 amp hour one, because then you're not carrying around as much weight. But if you have a saw or angle grinder, something that requires a lot of power, then you should at least buy a 4 amp hour, probably a 5, because then you actually get some value for all that weight. When I bought my first Makita battery, the biggest size you can get was 5 amp hours. But if you wanted bigger than that, you need to buy the knockoff one, which instead of 10 cells had 15. So the casings were even bigger and bulkier. But with the introduction of the 6 amp hour ones, you can see that the cells are getting better every year, so maybe soon we'll get a 3 amp battery with just 5 cells. And while we're off the record, let's talk about the 20 volt issue, because some batteries claim that they are 12, 20 and 40 volts, while others say 10.8, 18 and 36. And the bottom line is, it's basically the same thing, because it's the same cells in all batteries. Difference is what voltage you're talking about. The 18 volt battery talks about the nominal voltage, while the 20 volt battery talks about the maximum voltage. So it's all the same thing. I think this stems from olden days where you have a different kind of battery, and 12 volts was actually 12 volts. But nowadays with the Li-ion ones, it's 10.8, and as I said before, it doesn't really matter. And thus concludes the crash course. If you have any questions or if I've gotten something wrong, just write about it in the comments so we can all learn more. Now, let's bring the rest of the class back in 3, 2, 1. Welcome, time traveler. I hope you have something extra special planned for all that time you've saved. You haven't missed anything important, we're just taking the cases of the batteries. To do that, you need a TR10, that's a Torx with a hole in the middle. And if your battery has one of these white things, that's a plastic plug that needs to be drilled out if you want to get access to it. So, what have we got here? Well, this one obviously has lived a rough life. These 3 are definitely goners, and you can see in the casing as well that we got some leakage. So I don't have any high hopes for this one. Let's check it with the multimeter. Here we got 1.67, not giving a reading at all. 1.63, no reading at all, and 1.44. So yeah, all of these batteries are goners. Nothing much we can do about them. This bigger one looks a lot better. Let's see. That's a 4.08, 4.08, 4.08, still, and yeah, 4.08. So those cells all seem to be really functioning well. So here is probably something to do with the electronics instead. Let's move this one aside. And to have a closer analysis, you would want one of these capacitor controllers. And now we have to put in the correct type of battery. This is a Li-ion. So here we see the first cell, 40.08, 97%. The next, 40.69 at 96%. The third cell, same voltage, roughly the same. The fourth cell, roughly the same. The fifth cell, roughly the same. With a total of 20.40 at 96%. So everything looks brand spanking okay with this one. So there might be an issue somewhere underneath there. Maybe it just needs a good cleaning. Who knows? But say that we just had one cell that was broken and we wanted to replace it. How would we go about doing that? Well, if you look at the sides, you can see it's not as easy as in soldering away one battery and just soldering back another one, because these are not soldered. And there's a good reason for that, because you shouldn't solder batteries. One, it's a really tough surface to put solder on. And second, to get solder to actually stick, you have to put in a lot of heat. And a lot of heat in a battery, that more or less destroys it. So even if you get the connectors to actually stick, you would ruin the battery. So no soldering. What they have done here is spot welded. So you see that each of them has 4 spots, because you spot weld in pairs. So to do a proper job, you need a small spot welder. And that costs about as much as one of these batteries costs. But wait, I hear you say, I don't want to get a spot welder, that seems tedious. And if I can't solder them, maybe I can use one of these battery holders. I mean, they even come with wires attached. No, never ever do that. These wires are not rated for that kind of power. This is a wire rated for 10 amps These are not. But the battery is only 2 amps, I hear some of you say. No, that is not how current works. Let me clean up a bit here and I'll set up a test and show you what I mean. Oh boy, this is so exciting. I feel like Electro Boom. Here I have connected 5 batteries in series. Let's flip this one around so the wires aren't crossed. And they all run through this multimeter that's showing the current and connected to this drill. I mean, a drill doesn't take that much power, does it? Let's try it out. See, these wires, could you see that these wires were moving? I think that was a sign that they were going a bit of current through it. Not too much, but still enough for wires to move. But yeah, everything seems fine otherwise, doesn't it? Let's put some load on the motor and see if that changes anything. And here we see the magic smoke. I think that's enough to prove a point. So yeah, that's what happens if you try to use battery cases like that. So please don't. If you want to do battery surgery, get a spot welder. That's what I'm going to do. So I'll see you when it gets here. The package from Jeff Bezos' Horror Emporium has arrived. I try my very best to give that man as little money as possible, but sometimes when you want a special thing, supply and demand forces your hand. So let's see what we got here. 2 probes, that's the electrodes for the actual welding. 1 foot pedal to actually activate power. 1 teeny tiny little power supply to feed this one. Yeah. Feels a bit small, but sure, it probably works. And then some nickel strips, because this is what you use when you weld batteries together. While I was waiting for this one to arrive, I did some more research, and it turns out this might be trickier than I initially thought. This control board, or BMS, battery management system, actually does more than I gave it credit for, because it checks the voltage in each of the cells to make sure that they're the same, because same voltage, that's a sign of a healthy battery. And it has a temperature sensor that makes sure that the battery is not fire, so that's also a good thing. But what I didn't know is that it has a memory. So if you try to charge a battery with a fault 3 times, it will brick itself and never work again. And I think that's the problem with this one, because when I measure all the cells, everything looks fine, but it just won't take charge. So then it's not much you can do, except replace that board. So that's why I ordered some new boards from our friends in China. But while we wait for those to arrive, let's take a look at a smaller battery, because here you can see that this board is a lot simpler than the other one. These are just old school components, nothing here speaks of intelligence, so this one we might actually be able to do something with. So let's clean it up and see what we got to work with. When we're cleaning up battery acid, vinegar is the best bet. But first, let's try to remove this protection tape. Let's see if we can just break the spot welds. See there it popped free. To remove the leftover paper, acetone is probably your best bet. This probably would have been easier to do while the batteries were still attached. And here we see a difference with the old one compared to the new one, that this one only measures the big current and 1 battery, whilst the new version measures all the cells. So this should be easier to treat. Let's just hope the acetone doesn't melt the plastic. When I have used batteries like this, it's best to store them in the same direction, so all the positive on one side and all the negative on the other side. And this goes for all batteries. This is my used battery storage,
because this way, when you have, as in my case, all the positives at the top, it doesn't matter if you get a short somewhere, like some metal filings or something like that falling into the box, because then it's just positive to positive, and that's just a parallel connection and nothing will happen. But if some of the batteries are stored upside down, then you can get a loop if you're really unlucky, and then if there's some use left in the batteries, they might start to burn. And as I said before, please don't burn your shop down. So always store the batteries the same direction. Never have a battery salad. So now it's time for the fun part. And before we start, we have to make sure that we're doing it the right way. That is making sure that we put positive and negative at the correct places. You see here on the battery casing that we have plus and minus noted. Plus is the one with 2 connectors and minus is the one with only 1. So this is the minus one, and if you're at all worried that you're going to mess up, do as I do and do a little marking here with a minus and a plus on this side. Then you know that we connect it the right way. And if you have one of these cradles, then you should definitely put the batteries in those, because then you're sure that they're in the correct spacing. And before we put them in, if you have reused batteries, you should take a look at the spots left from when they were spot welded before. And if there's anyone that is a bit proud, just scrape it off with an X-Acto knife or sand it off, because then everything will go much smoother. And if you have one battery that's slightly stronger than the rest of them, then you should put that in this position, because that's the internal power for the control board. So if you put it that way, I'm going to place it like this. So then we want the negative here that goes to the positive, and from the positive we go to the negative, and so on, and so on, and so on, to get a nice serial positive to negative, and that sort of thing. And just to make sure that we don't get any temporary connections while we're welding, I'm gonna take some electrical tape and isolate this negative side when I put the housing on, because then there's no connection to be made all the way around. So then we're much safer. And some more electrical tape, just to make sure that everything stays in place while we are working on it. So now it's not much to do but to start the spot welder. And the eagle-eyed one, you can see that it's not plugged in, and that's because this apparently is a battery one. I didn't know that when I bought it. So yeah, so this one actually had 2 of these batteries inside it. So this battery is welding batteries. That's kind of neat. Let's go. Did I mention that I haven't done this before? Well, a wiser man maybe would have tried it out on something else, but yeah, what's the fun in that? Okay, here we go. 1, 2, 3. Well, that was underwhelming. Oh, there we go. Maximum power. Apparently, these ones are a bit too thick for this spot welder. So I guess we will have to remove them, because this works a lot better. Pretty decent. Okay, so what I'm gonna do is cut these ones down to size a bit. That might be a bit crude even for me. Like so. And then we'll take a new strip, something like this. It should be fine. So let's just spot weld it in place, because when you have a spot welder, everything seems like it needs to be spot welded. The foot pedal has this 3-second delay that makes sure that you can position the electrodes right. And you shouldn't do too many of them in a row, because then it's a risk that they're overheating. Yeah, you're probably fine. So that's one side down. The good and scary thing about this stage, that if you messed something up according to the directions of the batteries, you will notice at this part, because they will become very warm and probably ignite. So seeing that nothing has burned up, it's a good sign. So now we're at the scariest part, completing the circuit. And seeing that as nothing has blown up, this is a good sign. And let's do a measurement. Positive, negative. 20 volts. That's nice. Everything seems fine. Nothing is smoking. This might actually work. Okay, so now let's see how we're done. Well, that seems nice at least. No fire so far. But the moment of truth. What does the charger say? Well, it was worth a shot. At least we got the change angle control boards. That might work. The new BMSs have arrived, so this should be a pretty straightforward operation of it's just a matter of unsoldering the old ones and soldering on the new. So yeah, this is pretty close to being correct. Not 100%, but good enough. I'm sure it's gonna work. These extra electrical leads would probably be great if you want to use new batteries, but since we're gonna reuse the old ones, which is already well connected, I'm gonna try to reuse these, because I am lazy. Okay, and it seems like these ones are coated in something. Let's try to clean them off with some acetone. Whoa! Yeah, and this is why you have to be careful with live batteries. Don't short them out. This was just 2 cells being shorted out, but yeah, please be careful, and yeah, please don't do that. This is stupid. Don't do this. Oh boy, that was a lot more work than I anticipated. Now, before we solve this new one on, we need to check the batteries one last time. And if we want to do this exactly by the book, we should cut them up so we can check each cell individually. Because as it is at the moment, we can only check them in pairs. So if one of them is bad, then we won't know. But I can't see anything from the outside that it looks wrong. I mean, these 2 cells we can't really see. So I'm gonna go the lazy route and not do that. But let's do one last check on all the cells, just to be safe. Yeah, everything looks fine. So let's go with this. And before we do that, let's take a closer look at these 2. I mean, from the top side, the only difference is that this part that corresponds to this, we have to fabricate that. But otherwise, all the slots fit equally. And if you look on the other side, this is, I'm pretty sure, the temperature sensor from the old one, whereas the new one has that instead. So it's a bit different, and I guess this one gives a better reading, but it'll probably be fine. Yeah, it'll be fine. So considering that this one will be have to have a strip fabricated for it, I will save this one for last and try to focus on making a good connection here so that we don't get glitches, because that might be something that the board doesn't like either. So yeah, wish me luck. There's something not playing ball. Is it this one? Yes, this alignment pin is not cooperating. Because it bloody well isn't aligning with that hole. This one has to go. And now to not short circuit. That's good enough. Yes. Yes, it is. Might not be the best soldering I have ever done. But I'm trying my darndest not to. Short circuit. Don't like the sounds it's making. Got that one up there. And then we're going to spot weld the rest. Let's put a piece of paper in between so we don't get a connection directly. Here goes nothing. Whoa! That was a bit much. I think we can turn the juice down a bit when it's just 2 strips like these. Yeah, that was a lot better. So yeah, this might be it. Better let it cool down a bit so that the temperature sensor didn't trip anything. And just let it relax a bit. That only seems appropriate. Yes. Relax. We can take a closer look at you later. Yeah. Relax. And in the meantime, I'm gonna try and do the same for this one. But I mean, it's gonna be more or less the same, so probably not gonna film it. I already started to fabricate little thingies to actually make this work with the new board. So yeah, we'll let that rest, and I'll do this off camera, and then we'll go back and test if either of them work. Okay. Okay, moment of truth. Let's check them with the drill first. That looks good. And a bigger one. Nice. But the real test is the charger. What will it say? Let's start with the small one. Success! And the big one. Success! Nice. So I have proven that yes, you can fix a broken tool battery. The question is if you should. And I can't answer that for you. I know that I will be marking these ones as being tampered with and keep a close eye on them in the future, because I don't trust my handiwork, and neither should you. But if you feel like you want to try this at home, please take the proper precautions. As an example, I've had a metal trash can with a lid by my side this entire time, in case something went sideways. And if you're gonna buy a spot welder, I suggest getting one that can handle a bit thicker material than the one I got. 0.3 millimeters, that should be enough. But I rambled for far too long. Thank you very much for watching, and have a nice whatever you're having. And please, don't try this at home.